just a reminder, we do have this EU carbon roadmap. This is what the European Union promised to the world, that we're going to reduce carbon emissions by 80% until 2050. I mean, we talked a lot about the obligations, etc. I think we can stop here, but just with all the Brexit and Italy and Greece and whatever discussions, we kind of forgot this. This is current legislation. And this is from our lovely hometown Stuttgart. This is the truth. So the red line showing what should happen if we follow this EU carbon roadmap. The blue line shows the reality. And with all respect, I think a part of it is this belief in technology. We always believe that technology is going to bail us out. We always believe in some sort of innovation in technology, and the promise never happened. It was never fulfilled. And now we talk about smart cities and smart buildings, and it's the same thing again. Don't get me wrong, I don't want to say we have to go back to live in caves. Technology certainly has to improve, but technology will not provide us the solution, the ultimate solution. Just to give you, I totally agree what you said to system thinking. In terms of system thinking, friend Thomas Stark put together this very simple chart. I really love it. And he just looked at the way we're balancing. We always balance kilowatt hours per square meter in year, or carbon emissions per square meter in year. We always reference to an area. If we start to personalize, we get to a total different view of things. And he looked at, in this very simplified, personalized balance, he looked at three prototypical persons, men in this case, old white men, and their personal footprint just for housing, for living, and commuting, only those two sectors. And he said, Mr. Müller, he's living in a house on 200 square meter, just with another person, and the house is designed based on minimum energy standard requirements in Germany. And he drives with his C-Class Mercedes, obviously. Thomas is from Stuttgart as well. So with his mid-class car, he drives commutes 15 kilometers to work every day. Then this is his balance. So it's heating, hot water, appliances in his house, and commuting. Now he compared it to Mr. Meyer. He lives in a passive house on 160 square meter with 3 other people, so only 40 square meters is dedicated to him. But he drives his SUV. 30 kilometers to work per day to work this way. And suddenly this is his balance. So the house, and you could do 300% produce energy with your house. The commuting suddenly starts to determine his personal energy consumption. And this is, I come to this later. And then he looked at Mr. Schmidt. He lives in an Art Nouveau building built early 20th century on 130 square meter, and bikes every day to probably professor at the university in Stuttgart, bikes to work every day. And then suddenly this is his balance, because he lives in this old building on 130 square meters by himself. Now what's interesting, if you look at this, I mean, we don't want to insulate those beautiful Art Nouveau buildings or brick buildings, but if he would subrent one room to a student, the red bar would be cut in half. If he subrents 2 rooms to 2 students, he has the best balance all of a sudden, without touching the house. So we see how the metric we use is kind of misguiding what we are doing. And just to give you a nice example, just recently someone told me there's an architect here from the UK. He got the commission to design a school in a school complex, and looked like an extension to a school complex. And he looked at the schedules, and he said, if you reorganize your schedule, you don't need this building. And they looked at it, and they didn't build it. This is system thinking. And this is something a tool, let's say a sustainable certification tool, cannot do for us. We have to be smart as designers, and don't hand it over to some engineers to make it green. Just want to focus quickly, we said we talk also about solutions, on this question of chiller and air conditioning, how air conditioning is going to increase. This is from this study on air conditioning. Here we see, we are here somewhere, 2015, 2018, how the amount of air conditioners are going to increase. Prashant, you talked about India. And so only this single issue of air conditioning, if we continue on the path we are, is going to create a big problem. At the same time, I don't think we fully understand what provides comfort for people, what provides a comfortable environment. Doing a glass box and putting an air conditioner inside in the desert is not comfortable, even though you can cool the space, exposed to the sun with the blinds heating up to 50 degrees, radiating into the space and blowing then cold air on people's head is not a comfortable environment. So it's also this understanding of what is comfort, what provides comfort, I think is very important. And I want to show just two very simple examples we worked on. This is a school in Damascus where we worked with Atelier Lyon architects. And there was this desire, only European kids, European families at the time were putting their kids there. And Europeans are not used to live and work in air-conditioned environments. So there was this desire from the parents, started from the parents, to do this without air conditioning in Damascus, where they have every day in summer temperatures of 40, 45 degrees. But it cools down at nighttime. It's a desert climate, it's dry, no humidity, which is beautiful. It cools down at night to 20 degrees. So we studied the climate, we studied the site. This was obviously before the civil war there. What surprised to us to recognize that people in this environment, they prefer to live outside. This is a souk, like people spend most of their time outside. They don't go to shopping mall in this climate, and it's actually very comfortable. You start to recognize that with some vegetation, some shade, some breeze, it's actually, given the fact that it's very low humidity, it's actually a very comfortable environment. And we know scientifically proven that people do accept in an outdoor environment a much bigger temperature and humidity range than they would ever accept in an indoor environment. But we also know that people accept a wider temperature and humidity range in an indoor environment if the space is naturally ventilated, and became part of code here in Europe, in the United States, just nobody is using it. We do have these so-called adaptive comfort standards. This is scientifically proven, just nobody's using. We always try to blame code and regulations, etc. There are regulations which allow us to do a lot, we just have to use them. Okay, coming back to our little school. So we ended up with a scheme where we have this patio where we try to create a nicer microclimate. We have outside air. We run it through pipes which are embedded in the slab and cool it down on the way and then supply it into the space. And then it goes out by a solar chimney. And then more pipes that supply air into the upper space and also go out the solar chimney. And it's very simple. It has no air conditioner. It has no controls. It needed to be a low budget solution. It costed 500 euro per square meter in Damascus. Not sure how to translate it into our construction costs. But it was a very inexpensive building. The whole building, whole construction was paid by the Parents Association. So it needed to be very efficient and very inexpensive. There's no building control. There's a flap on this opening, and the kids, they have to operate it. If they don't operate it, they get 40 degrees inside. If they keep it open in winter, it's getting cold inside. So they're pretty fast. They learned how to use it. But when we work in Germany, for instance, in Germany in Waldorf schools, there is always this idea also that we have to involve in kids in this operation of, let's say, environmental control systems to get this knowledge back, to use it as part of the education, not as part to give them a hard time. So that's the idea. And then what we did, we oriented this chimney to the west so that we get the low sun angles, heating up this masonry wall. Late afternoon, and this was the most important part, so it heats up to 70, 80 degrees. It stays hot overnight to keep the natural ventilation going at nighttime, so that with cold air at nighttime, we cool down the slab, we cool down the ceilings, the thermal mass of the building, to kind of regenerate the building, make it comfortable for the next day. And we predicted that we're gonna get inside something like at the end of a day, at the end of a hot period, we're gonna get something like 30, 31 degrees. But we could show them with these adaptive comfort standards that this is actually within the comfort zone. And even the parents said 31 degrees at 45 outside seems to be totally fine. And before the Civil War, they wanted to extend the school using the same system again. So, which is always for us certain proof that they are kind of satisfied with it. So this is how it looks like. And what I always like is when these environmental systems also contribute to the aesthetic of a we are not architects. I mean, this is designed by the architects. And by the way, the chimneys are way too big. But he wanted to have it in a certain scale. But it doesn't matter. I think these are not the important things, but it contributes to the aesthetic of it, and we start to create synergies between design and operation, between design and function, with this external circulation through the courtyards, etc. We have to be more aspirational with what we are doing. We have to be more aspirational in the design process, and at the same time being inspirational with the products we create. And if we can get those things together, then it starts to become, hopefully, like a movement. I think that's what we want to achieve, getting into a movement. We talked about we can't stop this with the design of the house or the building. We also need to design the city. You said that, and totally true. And at the university with students, we do these so-called climate walks. So students on a backpack walk through a city and measure at every second, basically, the local microclimate. And it's quite interesting, coming back to you raised it about vernacular architecture, what vernacular architecture do. And vernacular architecture works very well. The interesting thing, not only in terms of building operation, but also in terms of how the city works and the climate of a city. And this was in Genoa. We did it in Hong Kong. We did it in Singapore. But we always try to find fancy spots. This one was in Genoa. And this is now UTCI. It's the metric we use for outdoor comfort. It's like the temperature people feel, taking mean radiant temperature, air movement from wind, etc. into account. But what you see here is a temperature of something like 25 degrees in this environment in Genoa, whereas here it's something like 40. So we get a difference of almost 15 degrees at the same moment, at the same point in time, only caused by design, only caused by the urban fabric, the urban form, and the material. Those are the two parameters. And this is how it looks like, where it's fairly comfortable, like this old Mediterranean type of urban environment, narrow streets, thermal mass, shaded by the neighboring building, exposed to the outside, wind going through at nighttime, cooling down at nighttime, keeping the city cold for the next day. And it works, and we show it here that it works perfectly fine. Here, it's more about this urban fabric. Here, this was a wider street. There we get a little more wind. This was the effect of wind. And then, not to blame any architect, but then Renzo Piano redesigned the waterfront, and this is the Renzo Piano site, which is the hardest you can find in Genoa, in the Genoa environment. No shading, exposed to the sun. Talking about vernacular, I mean, totally, we don't want to go back to vernacular, but getting this comprehensive understanding of the physics of the built environment and how buildings interact between inside and outside. We have to get this understanding back into design.